Hi, it's Sam. In this video, I'm going to show you how to take the code from the last video on buffer slicing in Gen and rewrite it in Codebox. A Codebox is a text-based way of programming in Gen. So we're just going to create another Gen patcher, and I'll just name this Codebox Slicing. Let's open that up. And I want to be able to see the code so that I can reference it, and we can kind of see how do we convert from one to the other. So we're just going to create a code box. And you can see it gives us a starting point of out1 equals in1 and in2. So the very top of our code in Codebox, we have to first declare any params, buffers, other kind of data containers like that. So we'll start by doing our params. We have slices, speed, the sampling rate of the buffer, and the on-off. And actually the speed one should be, we didn't end up using that, so I should get rid of that. So let's start off with on-off. So param, we have to have an uppercase P, then the name of it is on-off. Default of 0, min equals 0, max equals 1. Then we have to add a semicolon after every line. The next parameter, slices, default of 8, minimum of 4, maximum of 16, and then the sampling rate, we'll have a default of 44,100, and then buffer, again uppercase B in buffer, and I'm just going to call that SF, or that's the reference to the name of the buffer in the main patch. Okay, you see there was an error. Now that error is cleared. And we have the start of our patch by declaring our parameters and buffer. Now we can start to do the main part of the patch. Let's get some of the information that would be useful to have as a variable. So the first one would be the buffer length. So maybe we'll say like buffer length. And that's going to be the dimensions or the size of the sound file. We also want to know the counter increment, and that's going to be the buffer sampling rate divided by sample rate. And then we also should round the slices. So I'll just call this rounded. Actually, let's call it slices first. Slices round. We're going to round slices to the nearest whole integer. And then we also want the slice size, which is the buffer length divided by the slices. And lastly, we can get the kind of play status. Now we can just simply use these variables so we don't have to make a mess with putting all of these things in different places, all these calculations. Now to kind of check how you're doing, you can click outside of the code box and you'll get any errors if you have any errors going on. Since I'm not getting any errors, I guess we're fine so far. Now we can start moving on to the next section. So I'll start by getting the counter. So how this looks when we have something with multiple inlets and outlets like counter, we have the return values or the outlets, and then we have the operator arguments or the inlets on the right. If you have any unused return values, then those are going to show up as an underscore. So let's take a look at counter. So I want to get the counter index. So I'm going to call the outlet. So that's our first return value from counter. And I also want to get the carry flag. So I'll call that the counter trig. But I don't need the third outlet, so I'll just leave that blank using the underscore. And so I'm just separating these with commas and giving them my own name. And that's going to equal the counter operator. And we already created variables up here for what's going to go into these. We have the counter increment and the play status and the slice size. So we've calculated all of these up here. Just plop them into our counter. Okay. Now we should calculate the random slice. So the random slice is going to be, we kind of have to think backwards here. It's going to be, we're taking the floor of the absolute value of noise multiplied by the slices round. And then the current slice, we need to latch the random slice to the counter trig. We also need to get the current index that peak will be using. So to get that, we're going to get, let's see, current index. That's going to be the counter index plus the slice size times the current slice. So far, so good. Now, last, we have to get peak. So peak, similar to before, we have to get these return values. So I'm going to call this peak left and peak right. And then we don't need the other return value, so we'll use underscore. So peak's going to take, first I need the name of the buffer, so SF. and then the current index. Then I need the channel offset. This is necessary, so I need to put this in here. So the offset is going to be 0, so you want to start at channel 0. Now I can do interpolation. I'll say linear, and bound mode, I'll say wrap. Number of channels. Oops, no, that's right. Channels is 2. And channel mode is going to be wrap. Okay. Then lastly, we need to send out the signal. So we can actually do this like this: out 1, out 2. It's going to be peak left and peak right. So that made a second outlet. So here's out 1 and out 2. Okay. So let's give this a try now. Let's disconnect. Connect to you. And let's load in our sound. Oh, and nothing's happening. Let's take a look. Variable noise is not defined. Let's open this up. I'm guessing that I forgot to put parentheses. Yes, so noise. Oh. So there you have it. We've taken our original code and converted it into Codebox code. I hope you found this helpful. Please let me know if you have any questions or clarifications. Otherwise, until next time, class is dismissed.